Dear students, until now we have learned that how the data is stored in the computer and what are different strategies, and we have also learned that how data is manipulated using number of operations. However, user is not the one who is communicating with the hardware to get his or her task done by the computer. There is someone who is known as the overall in charge of the computer who is communicating with the user, taking the task, and then doing those tasks from hardware. So such an overall in charge of a computer is known as operating system. And in next few modules we will be learning about operating system, starting from its history and then how it has evolved from very basic operating systems until the very complex operating systems of today's computer. So in this module we will be mainly focusing on history of operating system. So first of all, we have formally defined an operating system, that is a software that controls the overall operation of a computer, and those operations are stored and retrieved files, execution of algorithms or programs, program scheduling, and memory management. So we will be learning these concepts in details in next few modules. And some of the examples of operating system are Windows. You might be familiar with Microsoft Windows because majority of computer have Windows as an operating system. And then there is another very famous operating system known as Unix. And there are two other operating systems which are based on Unix, such as Mac OS and Solaris. You know that early operating systems of 1940s and 1950s, they were occupying the whole room, and program execution required significant preparations. For example, we need to mount the magnetic tapes somewhere here, and then we need to place punch cards from where the data will be retrieved and where the data will be printed or stored, and then there are setting of switches. So all of such activities are somehow performed by this human who is kind of in charge of that time's computer, and you can say that this human is doing some of the activities of that time's operating system, of doing the mounting of magnetic tapes, placing punch cards, and setting up the switches. And execution of each program called the job was isolated activity. So each job, whatever need to be performed at that time, need to be done in the isolation. So we had already discussed that if a computer was made at that time who was responsible only for the calculations of addition, so then that job was done by that computer, and the person who was in charge was only setting up the switches and putting the punch cards for data retrieval and data writing to do that particular only one job, and which was in the isolated environment. A machine was shared between multiple users. So because that machine was very expensive, so users were coming to perform their task and to get their results from the same machine. So it was shared, but at one time only one job was being done. Then OS began as a system for simplifying program setup and streamlining the transition between the jobs. So the first step at that times of computers was to replace the operator, the users with the operator. So this means that different users are not going to the computer room. Instead, there should be a way that the users submit their jobs to someone called the operator, and that operator is helping to execute all of such jobs. So this is known as we are simplifying the program setup and we are streamlining the transition between the jobs, because one person would be handling it perfectly rather than different users are using the same machine or sharing the same machine. So beginning of operating system was we separated users and transition. Computer operator was hired to operate the machine as we discussed, and users submit their data and directions and instructions, which we nowadays called an algorithm, or the steps what need to be done on that particular data for that particular user. So they submit such instructions and data, and the program and the operator load this material in the mass storage of that time's computer, and OS was able to read one job after another job, and such a processing was known as batch processing. So let's see the batch processing in a visual way. So for example, different users have given jobs J1, J2, J3 and so on, and those jobs are going into the job queue somewhere here, and then one by one each job is going to be executed, and all of such operation was being performed by operator of that time. So the users are not interacting with the computer. Instead, the operator is doing all of such activities. And you might listen queue as a word in computer science many times, and the queue mean the same thing which we follow in our daily life. It's a line where people enter first and the first person should be served first. So it is called first in, first out. And the drawback of batch processing was that users were not able to interact with their program, because users have submitted their jobs somewhere here, and then if any job need some processing by the user, for example, if there is a program which is doing addition of two numbers, so this means that both of the numbers need to be inputted within the job as a static data so that the addition can be performed. However, if user want to enter the input at runtime, so there is no possibility, because the user is not able to see what is going on within the computer, as all of these things are being handled by the operator. So to fulfill this drawback, there was a concept known as interactive processing. In this interactive processing, in fact, there is a dialogue between the user through remote terminals. So for example, user has submitted his or her jobs to the operator, but those jobs are being executed within the computer and people can see it on different terminals. So for example, these are different computers called terminals, and these terminals have just a typewriter, or you can say the keyboard attached to them, and user, for example, user 1 can view his or her program status, whether it has been executed or not, by visiting this terminal. User 2 can see his or her status of the programs by visiting this terminal, and so on, user 3, user 4, and up till more users. So at that time, approximately 30 users were very efficiently serviced by such systems of that time. So this interactive processing have made it possible that users can communicate and can discuss and can see the results where what their program has produced. So if we summarize today's module, we have learned early operating systems, and we have seen that the one which is the overall in charge of computer is known as operating system, and how it has evolved. And we have seen the batch processing, where the jobs were executed in a batch, and then we have seen that the drawback of batch processing, which was that the user were not able to communicate with their programs on runtime, so that was solved using interactive processing.